All right, so for these examples, we're actually going to be looking for the rate. So it says Aubrey is going to invest $27,000 and leave it in an account for 10 years. Assuming that the interest is compounded continuously, so we know that we're going to be using our continuous formula. So we have A of t equals P sub 0 times E raised to k t or RT. So we're looking for the interest rate. So we're actually going to be solving for k or r, depending on which one variable you actually are using. Now, it said what would be required, what interest rate do we need if we would end up with 39,000? So we know right here that we have A of t, and we know we have a time of 10 years, and we know where we started. So if I plug all this in, I have 27,000 equals my initial value, and actually I put that in the wrong spot. Let me make that correction. We have 39,000 that we grew to, and we started with 27,000. So we have E raised to K, and my time is 10 years. So we're having to solve for K here. So just like we would do when we solved our problems before, we're trying to get this E raised to KT by itself. So we're going to start by dividing the 27,000. All right, and again, in previous videos, I've made the point of do not round these answers here. You do not want to round it, and then it potentially could mess it up. So I'm going to turn it back into a fraction. It's going to be 13 over 9, or you could have left it as the big numbers. Either way is fine with me. And then I have 10k. Now, this is where I can convert to a logarithm, or I could do the inequality rule. I like to do the inequality rule when I have my e, because if I do the natural logarithm and I do the equality rule, then I can cancel out stuff, and it actually will get solved a little bit faster. So I'm going to take the natural logarithm of both sides. And again, what that does is I have the ln of e. Those are going to cancel each other. And so that leaves me with the ln of 13 over 9 equals 10k. And then I'm just going to divide by 10. Now, when I do this, I'm going to get a decimal value. So we have the natural logarithm of 13 over 9, and that whole thing is being divided by 10. So k is approximately 0.03677. Now, we want to convert this back into a percentage. So it says to the nearest tenth of a percent. So the nearest tenth of a percent, so if I convert this back into a percentage, that means I would multiply this by 100, because remember we initially divided by 100. So we would multiply by 100. And then we're looking at my k value. So the tenth of a percent would be 3.7% of increase. All right, so a very similar problem, again, just a little bit different. So it says Layla is going to invest $5,200 and leave it in the account for 15 years, assuming the interest is compounded monthly. So we're going to be doing our compound formula this time. We're still going to solve for the rate, but we're going to end up with 13,800. So we have our compounded formula. So we have P sub 0, 1 plus R over N raised to NT. So we're going to be solving for R. So we have 13,800. Our initial value is 5,200. 1 plus R. Now my compound is going to be 12 because it said compounded monthly. And then I have 12 times 15. So once again, we're kind of at this situation where we've got to get that base by itself. Once we can get this base by itself, then we have a lot more that we can work with here. So I'm going to start by dividing by 5,200. All right, so we get, I'm going to turn that back into a fraction to make sure that we have an accurate answer. So now I have 1 plus R over 12 raised to, we can go ahead and simplify that if you'd like, 12 times 15, going to give me 180. Now, in this situation, if I convert this into a logarithm, I've now got 1 plus R over 12 in my base, and that's not going to help me any because I'm not going to be able to solve that in the base. So how do we handle this? Well, this particular situation is where we can take the root of any number that we want to. So I have an exponent of $180. So I can take the root of or excuse me, not $180. We have a exponent of 180. I can take the root of 180. Now, that might seem silly. However, it'll now get rid of your exponent and you can simply solve for r. My recommendation again is that I do not touch this number. So if I take the root of 180, then I have 69 over 26. That now leaves me with 1 plus r over 12. I can now subtract 1 and then multiply by 12. So if I subtract 1, I have the 180 root of 69 over 26 minus 1 outside of that root equals r over 12. And then I'm going to multiply the 12 to the other side. So I'm going to multiply by 12 here. Now, I have to be very careful when I plug all this in. So 12 times, and I'm going to take the 180 root of 69 over 26. Outside of that, minus 1. All right, and let me correct that because my minus 1 needs to be on the inside. There we go. So I have that r equals 0.06524. And they want us to round to the nearest tenth of a percent. So we would multiply that by 100, and we get 6.5% as my interest rate. So this one took a little bit more effort. It doesn't matter what exponent you have right here, but you would take the root of that and then finish solving using your inverse operations.